Well, good morning. Now I'm on to my next video, and this next video is going to be where I explain to you how I deviated from looking at whatever it was. Trying to figure out the obliquity of our galaxy in relation to the possible or theoretical event horizon of the wormhole. So I needed to look at the sun, and I needed to try and figure out, well, where is the sun how does the sun appear to us during the spring equinox, and where does that put the north polar orientation of our planet in relation to its ecliptic? So now I go and I start looking at the SDO photographs, and this is when I decided that after looking at the first and so many SDO photographs, I'm like, there's too much information here that I'm passing up if I don't look at it and save it as I'm looking at it. And it appears to me that over the course of time, like maybe a year or so, the SDO gallery might be changing in terms of which picture is in what order, and you can't really tell because when you're looking at the gallery you see photographs, and unless you have the best memory on the planet, it's kind of hard to remember whether it was, did I look at that one? It looks like one I looked at. They all look like one I looked at because they're all the sun. So you're like, I don't know if I looked at that one. Let me go look at it again. Nope, haven't looked at that one. I wonder if I missed the first one. Go back and look at that one. I wonder if that one was there when I was looking at that one over there. Maybe not, because I don't remember that one being there. I remember that one over there that I looked at when it was over here. So I decided to do a screenshot and keep track of the ones I'm looking at and mark them off as I go along. That way I can always go back. Oh, yeah, I looked at that one. What do I want to look at that again for? So, I'm looking at the sun stuff, and I'm looking at the corona, and the very first picture is titled by NASA, the Reappearing Coronal Hole. And I'm like, that looks like an extraordinarily large spiral density Poisson zone. And when I looked at some of the very first photographs I looked at about a year or so ago, you could see the spiral density Poisson zones. I call them Poisson zones because they seem like they're less active than the hotter coronal zone outside of them, and they do appear to be depressions in the surface of the corona. And well, hey, that might be why they're called holes. So they are related to these coronal holes, as they refer to them. And they were very tight, and they appear to be very similar to the spiral density fractures that we see on the Earth's surface. And that's what got me started on all this to begin with, was all the little curlicue spiral density fractures on the Earth. I'm like, that doesn't happen from a great big block of Earth moving across the planet. That happens from somebody stirring the coffee pot. Or mom turning on the blender. Good luck if you're fishing in Lake Victoria. So, anyhow, that's where I ended up on this. And so I'm going to go down here and pop that one open for us. See, there it is. Reappearing coronal hole. We could go back and see what I looked at, but basically I looked at the sun, the very first picture, minus this little blue outline right here. I'll get rid of it. Oh, gee, I guess I have to hit the delete button. Alright, so this is the actual photograph as it appeared to me. And, of course, here you have this great big bald spot. Maybe we should be referring to the big orange ball. Big orange ball. Big orange ball. Bob. Yeah. Okay, anyway. Maybe we should be referring to it as Baldy, right? It's got this big old bald cold spot up there. Bald guys are kind of cold up there. And then it comes down this way and goes down like that, and it's doing a little swirly cue. Well, then I see, if you look around over here, you see like a very, very nicely curved circular form, right? And that's the vortex at about 45 degrees perimeter from the core right here. All right, and I'm looking like that, and I'm like, I need to capture this. I need to put this in my records as something I analyzed, because there's too many things I'm seeing here that I need to share with folks. And what am I sharing? I'm sharing the fact that this globe of our sun is rotating just like the Earth is beneath our feet. We just can't see it, and it isn't active in our crust because the Earth is cold enough so that the crust is thick enough that the vortices that operate beneath it do not affect the surface entirely. They do affect the surface. That's why we keep getting little volcanic pops going off everywhere, and it's also why we keep getting earthquakes along these fractures, right? And they're still under pressure. They're under that movement, the constant spinning underneath, and the constant counterflows of the lithostream. Okay? So, anyhow, I looked at that and I said, I can't just keep looking for the perfect sunshots by the SDO that occurred during the month of March. So now I capture this, I do my circle here. Well, let me go back. I'm going to go back and put my circle back on there. And I outline my vertical identifying stripes around the Earth. And for some reason, I didn't think to do the North Pole, the Arctic vortex line, or any of the east, west, and south lines. So I just did the circles. And then, I put the circles together here. I needed to determine exactly, when you're looking at the circumference of the sphere, how large or how high and how far out does your perimeter go at 45 degrees visually? And it goes out pretty far, as you can see right here. This is a 45-degree circle we're looking at right here. 90 degrees from one side to the other. And it's about, 5.4 inch in the black one, maybe I should have had the blue one on top. The black one's 4.6 inch in diameter, and the blue one is 5.4 inch in diameter. And then we go down here and we do the math. Okay, yeah, you're all excited about the math, me too. And then I come down here, the circumference of my sun photograph here in my PPT is 6.1 inch. And then we figure out the math by terms of ratio and blah, 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 and into the math. Okay. Now down here I take my circumdicals and I put them onto the sun. And bam. Lo and behold, if that same 45-degree circle at that ratio is right smack on that nice formation of what appears to be a circle on the sun. Then we're looking at this spiral density fracture, very large one, as I'm referring to it to begin with, right? It's the reappearing coronal hole. And you'll notice that it comes around and hooks out like this, out toward the right, and then swoops down at the bottom toward the left. And I'm thinking, okay, well, if it's a spiral density posile zone, that means that it's being dragged like a rope. So if it's going in this direction, being dragged like a rope. So here's the core where my cursor is. If I follow it to the left, south, going back to the east, up toward the north, back toward the west, and up toward the north again, then that tells me that the vortex that this particular spiral density posile zone is in is rotating clockwise, because it's rotating in the opposite direction of the swirly cube. Okay, I mean, just think about it. How do these guys, these candy companies, put that great big lollipop together with all the little rolls of candy, right? So there it is. That was my first one. Don't ask me why at the first one I didn't apply all the other theories that I have at this point. I was just pointing out to NASA that there's a sphere right here, and that's pretty much what it is. So what we see here is an extraordinarily large spiral density puzzle zone. The center of this vortical core appears to be below the solar equator, indicating its mate on the other side of the sun will be positioned above the solar equator. Yeah, that was my point. Okay, so there's a heck of a lot more going on with this guy here. I go back to him later, and I do an update to the PPT, a change. That's when I slap on all the other analyses of the other forces that are taking place on the surface of the sun at the time this photograph was taken. And it's pretty exciting. And there's another theory that creeped in there, but I don't want to tell you about it right now. It has to do with what we're looking at right here. And it has also a relative likeness to the planet we live on, ladies and gentlemen, and that is exactly what I intend to prove later on. And that's the type of thing that's going to revolutionize the way we look at astrogeophysics in terms of planetary evolution. The evolution of suns, if there is such a thing. I mean, well, yeah, there is, because they're evolving as they become great big red giants, so on and so forth, that whole thing. All right, that concludes this video of the reappearing coronal hole, and this is in my series titled DRCB, Solar Dynamics. And I think maybe I will make this my new... because it's separate from me trying to figure out the obliquity of the solar system and the galaxy in relation to the wormhole. So, the theoretical wormhole, thank you very much. I mean, everybody else is talking about the possibility of wormholes exist, and now I'm telling you, I think I see one. If people start to look at the things that I'm looking at right here, and they think about the things that I'm saying, and they begin to see the things that I'm showing, maybe somewhere along the line people might be like, maybe that guy's right. Maybe that is a frickin' wormhole. Well, until we get the right instruments to tell us it is, we might not ever know before we get wiped out by an asteroid. An asteroid so large it knocks our planet clean off its axis, and it turns our planet into a frickin' molten blender, and everybody just goes boop, boop, and then everything goes berserk, and we never see the day because we pooped around too long, wasting time on killing each other. Yeah, so busy killing each other we can't pay attention to the real threats. Yeah, so it's like, whatever. Okay, anyway. Here it goes. Let me go ahead and close this out.